Assalamualaikum. So today video is about network in graph theory. First is what is network and what is the relationship between a network and a graph. Basically, in the field of mathematics, graph theory in a particular a graph is interpreted as a series of dots which are either linked or not linked to one another by lines. And a network basically is a part of a graph with the vertices and edges having their own characteristics. Each dot is known as vertex and the line joining two vertices is known as an edge. Next, we move on to simple graph. What is simple graph? A simple graph has no loops and no multiple edges. The sum of degrees of the graph is twice the number of edges. And here, look first at my memory. V stands for set of vertices and E stands for set of edges. And as you can see here, is the one of the example of the simple graph. Given question A, V and number of V, how to determine the set of vertices? Look at here, is 1, 2, 3, 4, 5, 6. And number of set of vertices is 6. And next, B, E and number of E. How to determine set of edges? Look at the line joining to point here. First is 1, 2, 1, 5. 1, 2, 1, 5. And next, 2, 3, 2, 4. 2, 3, 2, 4, and so on. And the number of set of edges is 7. And lastly, C, sum of degrees. Sum of degrees of the graph is twice the number of edges. So here, the number of set of edges is 7 and the twice is 14. Other than simple graph, there is graph with multiple edges and loops. So what is multiple edges and loops? The characteristic for multiple edges are involve two vertices. The vertices are connected by more than one edge, and the sum of degrees is twice the number of edges. And the characteristic for loops are involve one vertex. The edges is in the form of an arc that starts and ends at the same vertex, and each loop adds 2 to the degree. As you can see here is the example for graph with multiple edges and loops. And here is V set of vertices are A, B, C, D, and the set of edges are A, B, and another A, B because it is multiple edges. And here is D, D because it is a loop. So here is another example of graph with multiple edges and loops. Given question V and number of V. V is P, Q, R, S, T, and U, and number of V is 6. For B, E set of edges is PU and another PU because it is multiple edges. And here is SS because it is a loop. And number of E is 10. So C, sum of degrees is 20 because it is twice the number of edges. So next is directed graph and undirected graph. A directed graph is a graph in which a direction is assigned to the edge connecting two vertices. An undirected graph is a simple graph or a graph with loops and multiple edges drawn without any direction being assigned. As you can see here is a table based on simple graph. For undirected graph, there is no direction being assigned to the graph. And for the set V is A, B, C, and D, and set of edges is A, B, A, C, B, C, and C, D. The order of the vertices written is not important. For the sum of degrees is the twice number of set of edges, that is 8. For the directed graph, as you can see here, there are direction being assigned in the graph. For the set V is A, B, C, and D. For the set of edges, the order of the vertices is written according to the direction of the edge. And as you can see here, A, B, A, and C, A. Next, B, B, C, and D, D, C. The sum of degrees are according to the direction. That is, D in A means the number of edges going into vertex A. And D out A means the number of edges coming out from vertex A. And that is the same for the other vertex. And so the sum of degrees is 8. For graph with multiple edges, undirected graph and directed graph. Set V and set E for undirected graph. V is PQ, R, S, and T. For the set of edges is PT, PQ, QR, QR, QS, ST, and TT. And sum of degrees is twice the number of set of edges, that is 14. For directed graph is set of V is PQRS and T, and set of edges is PQ, QR, RQ, SQ, TS, TT, and TP, and sum of degrees is 14. For the second last is weighted graph and unweighted graph. For the weighted graph, type of graph is directed graph and undirected graph, and age is associated with a value or a weight. For the example, the age represents distance between two cities or traveling time. For unweighted graph, type of graph is directed graph and undirected graph, and age is not associated with a value or weight. For the example, the age relates information like job hierarchy in an organization chart or flow map. As you can see here, is a question related to this type of graph. The diagram on the right shows one-way paths that Izarul can choose for his running practice. Vertex V1 is the starting position and vertex V5 is the ending position before he goes home. Determine A, the shortest distance from V1 to V5. So the shortest distance is V1, V2, and V5. That is 600 plus 500 meter equal to 1100 meter, that is equal to 1.1 kilometer. And B, longest distance from V1 to V5 is V1 to V2 to V3 to V4 and to V5. That is sum of all the paths is 2500 meter, that equal to 2.5 kilometer. And for C, you can calculate it by yourself, and if you get this answer, then you are smart. For the last subtopic is subgraph entries. What is subgraph? A subgraph is part of a graph or the whole graph redrawn without changing the original position of the vertices and edges. And a tree of a graph is a subgraph of the graph with the following properties. A simple graph without loops and multiple edges. And B, all the vertices are connected and each pair of vertices is connected by only one edge. And C, number of edges equal to number of vertices minus 1. Number of vertices equal to n. Number of edges equal to n minus 1. So here is some of the examples related to subgraph and trees. Determine whether diagram 1, diagram 2, diagram 3, and diagram 4 are the subgraph of graph G. So here graph G is the original graph, and we have to determine whether the diagram is the subgraph of graph G. Yes, so the answer is for the diagram 1. Do you think this is the subgraph of graph G? The answer is yes, because the vertex pair for HE is the same. Look as here, this is some of the part from the original graph, that is PS, and diagram 1 is same as the original one. For the second diagram is no, because the position of loop E2 is not on vertex Q. Oh sorry, is not on vertex P. For the diagram 3, the answer is no, because the edge connecting vertex P and vertex S is not E3, and the original one is E5. For the diagram 4, the answer is also no, because the loop and the edge connecting vertex Q and vertex R are wrong. Q and R is not E2, it is E3. This is for the subgraph, and for the trees and the diagram 1. As you can see here, diagram 1 is a tree. Why? It is because all vertices are connected. Every pair of vertices is connected by an edge only, and there are no loops or multiple edges. There is 5 vertices and 4 edges. For the diagram 2 is not a tree, because vertex B and vertex E can be connected in 2 ways, and B, E, B, C, D, E. And lastly, 5 vertices, 5 edges. I think that is all for today, and I hope this video can help you in learning the topic network in graph theory. Hope can see you next time. Thank you.